I should go to Todd Desiato now. Todd is here, and we're squeezing our schedule a little bit, but
Can you hear me?
I can.
Coming through.
Todd, let me hand things over to you, sir. Welcome back. It has been a while. You have a lot to share. And you were talking about, yes, spin stabilized magnetic levitation versus gravity. Now I will hand things over to you and mute myself out.
Okay. Let me know if I can't hear me or something. Okay, so last year around this time, I did a talk about quantum gravity from atomic resonance states. And in that model, I discussed the harmonic oscillator in a gravity well. And in the gravity well, from the perspective of an outside observer looking from far away down into the gravity well, the oscillator falling into a gravity well is losing power. And that's depicted here by this first equation. You have so you're subtracting a delta P for power. And anti-gravity and warp drive are the opposite. So the total power of the oscillator is increasing. And the reason this is relevant is that in the polarizable vacuum representation of general relativity, originally by Halpatov, this coincides with a variable speed of light due to a variable refractive index caused by gravity. What I've shown in the previous presentation was that this can also be modeled by quantum radiative damping acting on the harmonic oscillator. The effects of radiative damping and the effects of gravity appear to be identical. So with that in mind, you can have a potential and just an arbitrary binding potential, but I propose that we take Planck's constant times the gyromagnetic ratio times the magnitude of the magnetic flux density. And this was related to gauge potentials and magnetic flux density, the magnitude of the magnetic flux density affecting the frequency of subatomic particles. In other words, the Compton frequency of an electron, for example, is affected by the magnitude of a scalar magnitude of a magnetic flux density. So from that scalar magnetic flux density, we define that as chi, and it's the sum of all the quanta of magnetic flux, the Webers or the Weber field. And from that, we can apply Poisson's equation and calculate solutions. And this led to mimicking free fall in a gravitational field using NMR, nuclear magnetic resonance, or electron paramagnetic spin resonance, or dynamic nuclear orientation. Last year, I started out working on building my own NMR machine. I had to build a zero Gauss chamber. And at the end of the day, I couldn't get it to work because the weight that I need to measure a change in weight due to the effect of this equation in a gradient magnitude of a B field, that my scale balance, I never got it to work, and I'm still kind of working on it. And then Mark is still working on the Alzaphon experiment, which is the same thing. He's going to look for a change in weight of a test sample. Sorry. And then, and these are the experiments that we had proposed last year. Then this came along, the Graviflyer by Alexey Chekurkov. And this thing is not a drone. There's no propellers, and it apparently levitates. He has many videos on his website, which is a YouTube channel called Technologies from the Garage, for those of you that can't read Russian. And it's got he's got a lot more than 4 videos there about the Graviflyer, and he goes to great lengths to try to show it's real. And he even provides a schematic. He's got diagrams and a spinning disk exerting a force upward. There's a motor, there's the spinning discs, and then he's got, he's shows close-ups of it. You can see under here, it's a lot like what was proposed earlier with the spinning magnets on an iron steel disc. And then he's got another disc above it that spins they counter rotate each other. And then he's got high voltage, supposedly about 30 kilovolts applied, negative to the bottom disc and positive to the top disc. And here's a diagram of it: negative to the bottom disc, positive to the top disc, with a Tesla coil attached to the center disc and the vertical support posts, and a little regulator and an oscillator that generate an ultrasonic frequency. This little speaker cone on the top is the ultrasonic speaker. Although in the video here on the bottom left, there's no audible sound of that oscillator. On other videos like this one over here, you can hear it at about 12.4 kilohertz. I'm not sure it does anything. I'm not sure the Tesla coil does anything because it's not a hardwired connection. It's just floating. And when you touch it, that charge gets grounded to zero and the thing still flies. Here's a picture. He's kicking it and it comes right back. And when it's sitting there hovering, it's like it's pinned to that spot, like magnetic levitation and flux pinning. And that's just the way it behaves. So again, I'm not sure that the Tesla coil actually does anything because he can touch it while it's flying, which grounds this out because this is not a hardwired connection. It's just a close proximity and it still flies. And I'm not sure this ultrasonic resonator has any effect because he touches it and it still flies and it doesn't seem to change anything. And in some videos, it's not working. You don't hear it. So the gist of it is the spinning magnets and the counter rotating plate above it is like a spinning parallel plate capacitor with magnets. And this reminded me of this little homemade toy. It's a homemade toy that you can watch this video on YouTube. The guy makes it out of magnets and a CD case, and makes a little spinning top and can make it levitate. And if you have ever heard of a Levitron, it's the same thing. I used to have one. In fact, I still do, but I could never get it to work. But that's what Alexey has, is the same kind of configuration, all the magnets facing the same direction, but it's the magnets that are spinning. And I think it's the earth that's the top, and that makes it levitate. And so I went investigating this and I found this paper, very informative paper. And it says that the stability of the Levitron cannot be explained if the top's axis has a fixed direction in space. Stability against flipping is not enough. Gyroscopic precession around the local magnetic field direction is necessary. An analysis and numerical integration of the equations of motion for an experimental stemless top that includes gyroscopic precession around the local magnetic field lines predict that the top will be supported stably up to spin speeds of about 3,065 RPM. An upper spin limit of 2,779 RPM for this top is observed experimentally and explained as an adiabatic condition. And spin-stabilized magnetic levitation is a macroscopic analog of magnetic gradient traps used to confine particles with a quantum magnetic moment. And that's very important, the quantum magnetic moment. Now, Alexey says his motor is spinning just around 3,000 RPM. And we measured it based on the sound of the motor, that it's probably around 2,800 RPM. So it's right in that range where their paper says it should be. And this is what they modeled. It was basically a ring magnet, polarized so the two flat faces are, the flat face is north and the bottom flat face is south. And the spinning top has the bottom flat face is north and the top flat face is south. And you can see here it precesses about the magnetic flux lines. The gyroscopic action must do more than prevent the top from flipping. It must act to continuously align the top's precession axis to the local magnetic field direction. Under suitable conditions, the component of the magnetic moment along the local magnetic field direction is an adiabatic invariant. When these conditions are met, the potential energy depends only on the magnitude of the magnetic field and gravity. While each component of the magnetic field must satisfy Laplace's equation, the magnitude of the magnetic field does not. This allows the curvature of the potential energy to concave up, not a saddle point, at the levitation height, forming like a bowl for the top to sit in. And the fact that this force depends on the magnitude of the magnetic field matches what I was saying, a year ago back here with this equation, with the magnitude of the magnetic flux acting like a gravitational potential. So it's the same thing. So now he gives these equations with the torque, and this is the force we're talking about that centers it and holds it in place. And then this is the equation for the precession frequency around the magnetic flux lines. And, we know the gradient of the gravitational potential, Newtonian potential, is what gives us G. So this is a gradient force and this is a gradient force. So their combined potential gives us this. And if you take the dot product is the magnitude of the two vectors times the cosine of the angle between them. And in this case, the magnetic moment is parallel to the magnetic field, so there's no cosine term. So you can just substitute in the values mu b plus mgz. And this is your potential energy function that lifts and supports the top. This equation here for the precession frequency is exactly the same precession frequency that we had in the NMR experiment and in nuclear magnetic resonance and in the Alzaphan electron spin resonance experiment. This is exactly the same thing. It's not a different thing. The NMR experiment, the Alzaphan experiment, and relating this to gravity is the same thing as this device that Alexey came up with. And that surprised me. But we were all in the group, we were all trying to find a way to explain this thing. There's at least 5 groups right now that are replicating this. And rather than try to replicate everything he did and hope it works, I'm going through it methodically, step by step, starting with the spinning magnets and then adding the charge and adding a parallel plate across on top of it. And I'm going to try several things that would effectively solve this equation here, equation 2. You have a gradient in the magnetic field and a gradient in the magnetic moment. And this leads to a force or a change in the potential energy over a change in height. And as you can see, if we take out that gyromagnetic ratio, then we have the gyromagnetic ratio is the charge to mass ratio. And like I said, Alexey is charging those disks. And then you have this magnitude magnetic field gives you a frequency. So if you pull out the gyromagnetic ratio out of your magnetic moment and effectively just to clarify it, if you have a moment of inertia, I, and you multiply the moment of inertia by the gyromagnetic ratio, Q over M, you get a magnetic moment. And that's how you model the magnetic moment. It's the same as the angular momentum multiplied, by a charge to mass ratio, which basically takes out the mass term from angular momentum and puts in the charge term instead. And so it breaks down to the angular momentum times the difference in frequency, or the time dilation between the height Z1 and Z2. So now we have parallel angular momentum and the frequency, but now in terms of gravity, the gravitational potential is basically identical. You have mg times height Z2 minus Z1, which you can replace m by the Compton frequency times Planck's constant. So this is divided by c squared is your mass term. So h omega c, g z over c squared is unitless. So this is essentially the angular momentum times the difference in frequency between the two heights. It's exactly the same. So this magnetic potential and the gravitational potential, it's just a mimic of it. It's the same equation. I hate when I do that. So it's equivalent to gravitomagnetism by similarity, because the gravitomagnetic field has units of angular frequency. Its units are hertz or radians per second. So you have this potential due to Planck's constant and the gyromagnetic ratio and the magnitude of the magnetic flux density, which is equivalent to the magnitude of the magnetic moment times the flux density. But if you paired it the other way, like if you pair Planck's constant with the gyromagnetic ratio, you get the magnetic moment. But if you pair the gyromagnetic ratio with the magnetic field, you get a frequency, which is a gravitomagnetic field. So essentially the precession frequency, which is gamma b, is also equal to gamma squared over GE naught times the gravitomagnetic field. So this is linearly related by this value here to the gravitomagnetic field. And so this is really amplifying the gravitomagnetic field using the gyromagnetic ratio of the particles, or in this case, the disk. Now this came as a surprise to me, and I want to, it's not really that important yet, but it might be. In 1994, and was mentioned earlier today, about Alcubierre's warp drive metric equation, and this is it. And yeah, I know I'm using the Z instead of X because it looks cooler. And then in 2003, I wrote a paper called Warp Drive Propulsion and Maxwell's Equations. It's available on ResearchGate. And in that, I used the line element plus the interaction term, Lagrangian density, I should say the Lagrangian density of the line element, plus the Lagrangian density of the interaction between electromagnetism and charged particles, basically JA, where J is the current density and A is the magnetic vector potential. So when you take those two pieces in the Lagrangian density and you square them, you get term for term the Alcubierre metric, where the VSRS, the ship velocity, and the ship frame bubble correspond to the charge to mass ratio over the speed of light times the electromagnetic gauge potential energy, I should say. So this is basically the same potential we had before. It is exactly equivalent if you're talking about a circular current and the magnetic flux flowing through that area and the A field around the perimeter, you get exactly that mu dot B is QV dot A, or V is velocity, orthogonal to the direction of the ship velocity. So if we just model a parallel plate capacitor, and this is the voltage, we've solved the equation that creates Alcubierre's metric in electromagnetic potentials. And from this, if you take the gradients of the potential, you get a force, which is what we were talking about. So here's that equation 2 again. Here's your disk with the 6 magnets around. It's Mark, this is the one Mark made for me, but I added a mu metal cover on it. So it's a thin disk of mu metal attached to an aluminum disc behind it. Now, Mark had the convenience of a CNC machine and made his out of copper and mu metal. And this all came up after we had already made the aluminum ones and he had already shipped them to me. So, so we're working on that. Hopefully we're both working on the same kind of experiment. But what I wanted to point out is I got this graphic from kjmagnetics.com, and it shows a disc magnet on a steel plate. And you can see the flux lines, magnetic flux lines here, and the magnetic field in the Z direction here has a gradient. From the bottom of the steel plate to the top, the Z field magnetic field is increasing. And this is inside a, quote, metamaterial. This is a steel disc, but it's the gradient in the magnetic field inside the material that matters. And now we're going to put a charge on this disc and we're going to spin it to create a magnetic moment. And the magnetic moment acting on the gradient in the magnetic field will generate this force. And since the gradient is in the Z direction, this disk should exert a levitation orthogonal to the velocity V, just like I said in the 2003 warp drive paper. So it's the same thing. We finally found the solution to it. And this matches Alexey's graviflyer, and all of this comes together. Even this is mu metal. This is the permeability of mu metal, or these diagonals here. And this is like a BH curve. And you can see that with a DC magnetic field right through here, the permeability is changing. So you've got a gradient in the permeability in the magnetic plate in the variable magnetic field. So here where I'm saying you've got a gradient in the Z direction of the magnetic field, there's also a permeability gradient in here because the permeability is not constant at these different values of the magnetic flux density. So those two things put together give us a gravitational like effect off of this spinning charged disk with magnets. So there's evidence of a flying machine that hypothetically may work by ultrasonic resonance. It could be an ion accelerator. The high voltage on the disks could be accelerating air. And or it could be due to gradient forces mimicking gravitomagnetism. It clearly, the behavior of it when it's floating there, it clearly resembles spin stabilized magnetic levitation. It doesn't resemble a drone with propellers. It doesn't resemble something hanging on a string that would swing and wobble around and things like that. It doesn't behave like that at all. And I can't attribute all of that to just the wires hanging off the bottom. It's really, it locks itself like magnetic pinning. So the same gradient forces may be interpreted as the 2003 electrogravomagnetic, that was what we called it, Rick Storti and I, the EGM warp drive equation proposed by myself and Rick Storti in 2003. And experiments are currently being conducted by 5 or more members of our group, including Falcon Space and myself. So there's more to come. I tried to get this thing built this week, but I didn't get it done. I bought a little high voltage power supply unit. Where'd it go? This little thing, hard to see. Just a little power supply unit. It's supposed to put out 15,000 volts, but I think I must have miswired the transformer because there's no instructions and it didn't work. So I got to take it back apart and correct that. And I'm not sure it'll give me enough power to do what I want to do. I've got some other parts on the way, but they won't be here till like Tuesday or Wednesday. Hopefully by the next meeting, I might have something to demonstrate. We shall see. Last of all, I'd like to thank you all for coming to these meetings. So the folks here at APEC, we really appreciate it, and we're growing by leaps and bounds. But I also have my own little YouTube channel. I've posted a couple of videos documenting my progress, building my own Graviflyer, making my discs, the U-metal disc, showing you Mark's discs, all this stuff. And it's all on my Warp Drive Tech channel. And I have, for anybody who'd like to support, because I am mostly self-funded, Mark was generous enough to send me those discs, no charge, and Jeremiah has helped me out quite a bit. But I do have, for anybody else who wants to help us out, I have PayPal and a Patreon, but I don't hide anything there. Everything you want is, I put it on YouTube and it's freely available. So, you're just doing it because you want to support us. So I think that's it. We can go to Q&A really quick, and then
Yeah.
we can be done.
Well, Todd, let me do this really quick. So I want to read those out though. So the one on top is paypal.me/warpdrivetech. Can they just go there? There's
Yeah.
It looks like there's more to it. So
The
PayPal.
question local, question mark local.
Question mark local. Okay. And then the second one is patreon.com/warpdrivetech. And again, you're not holding anything back, but again, if people want to support you, they can go there to donate, and that would go into the parts fund and all that kind of stuff. So
Believe me, Amazon loves me. I buy a lot of parts on Amazon and McMaster Car, and they're coming to my house almost every day this week.
yeah. Well, but before we do Q&A, let me do this. We have to applaud for you. Oops. And okay, let me remove spotlight. Let me stop sharing there.
There.
And everyone, please give Todd an enormous hand.
Thank you.
And Todd, that was a great presentation.